add two vectors which are aligned purely along the x-axis, that is in terms of I cap, it is simple. If we have a vector over here, that is 2i cap, and we have a vector over here, that is this is 3i cap, because this way it is I cap positive unit vector, this way we have minus I cap, this way we have j cap unit vector, and this way we have minus j cap, and up the plane it is k cap, and down the plane it is minus k cap. So this displacement is going to be 2i cap. If it is meter, so it is 2i cap meter, and this is 3i cap meter. So if you have to add the two vectors, the first thing is move a vector parallel to itself so that tail of this is joined with the head of this. So it means if this is 3i, we move a vector parallel to itself, so it comes over here. So this is 3 units, it comes over here, 1, 2, 3. So this is also 3i cap. When we move a vector parallel to itself, it doesn't change. So what we have done is, we have moved this vector, joined them from head to tail, and now from this tail to this head, this is a resultant vector. So 2i plus 3i, they are in straight line, so it is going to be the resultant of this vector, if we call it as A and we call this as B. So A vector plus B vector is going to be 2i plus 3i, that is 5i cap. If this, instead of like this, if we have vector like this, that is in this direction, so this is minus 3i cap. So then what we'll do is, this is 2i cap, and we have another vector in this direction. So this is minus 3i cap. So how to add these vectors? The method remains same. So this is 2i cap. The tail of this is joined with the head of this, so it comes like this. From the tail of first to the head of second, that is minus I cap, is the resultant of these two vectors. We have done the same thing, that is joined the vectors, that is head of one to the tail of other, and from the tail of first vector to the head of the second vector is going to give the resultant vector. Same thing we can do when the vectors, they are aligned purely along the y-axis or z-axis. But what if the vectors, they are not aligned purely along x or y-axis? Like over here, let's take a case of one vector which is like this, another vector is like this. We have to add these vectors, vector A and vector B. We have to add these vectors. So what we do is, first we break into components, that is if you have to find the resultant vector, like cases like this, obviously all the vectors, they can be written in vector notation. And we say in vector notation, it means what is happening purely along x-axis and what is happening purely along y-axis and what is happening purely along z-axis. It means we find the components purely along x-axis and along y-axis and along z-axis, and then the components of these vectors along the x-axis, they are added separately, along y-axis added separately, along z-axis separately, and we add this and we say this is the resultant vector in terms of I cap, j cap and k cap. Let's see over here. If in the simplest form, if we understand it as a displacement vector, though it could be a velocity vector, it could be a momentum vector, it could be a force vector, it could be any vector representing any physical quantity, but the method approach remains same. So this vector, which is aligned with the x-axis at some angle, this can be broken along the x-axis also, along the y-axis also. So what are its components? If you are to go from here to here and you are constrained to move purely along x-axis or y-axis or z-axis, so to reach from here to here, what you will do is, first you will go from here to here and go from here to here then. So it means this is going to 1, 2, 3. This is 3i cap and this is 1j cap. So A can be written as, so vector A can be written as 3i cap plus 1j cap. Now what is this vector? This vector, when we move it parallel to itself, it doesn't change. So it is 1 unit this way and 2 units this way. And now we have to move it parallel to itself and we have to connect its tail to the head of this. So that is 1 unit this way and 2 units this way. 1 unit this way, 2 units this way. That is, it goes like this. So what is this vector? This vector is, this way it is how much? That is, once again we have to break this vector, which is not purely along the x-axis or along y-axis or z-axis. It is inclined at an angle with the x-axis, y-axis, and it is lying in the plane of xy plane. So we break it into components, that is, from here to here we can go first like this and then like this. That is, first go from here to here and then go from here to here. So this vector is result of this plus this. We are using a triangle of vector addition only. So this is vector B is going to be 1i cap plus 2j cap, right? So we have vector A and vector B written in form of I and j. So now what we do is we have to find the resultant of these two vectors, that is A and B. So resultant is going to be, that is from the tail of first to the head of second. So this is going to be the resultant. So this is going to the resultant vector, and this resultant vector is going to be A plus B, and once again this can also be broken along the x-axis and along the y-axis. That is, if we have to go from here to here, first we can go from here to here and then from here to here. So what is this? This is 1, 2, 3, 4. So this is 4i cap, and this is 1, 2, 3, 3i cap. So this resultant is going to be equal to, that is resultant vector is going to be 4i cap plus this is 3j cap, 3j cap. Also if we see over here, that is we say A is equal to 3i plus 1j cap, and B vector is 1i cap plus 2j cap. If we add I in I, that is in x and x, obviously they can be added together. In I we add I, in j we add j, in k we add k. So resultant vector, that is A plus B, is going to 3i plus 4i, 3i plus 1i is 4i, 1j plus 2j is going to be plus 3j. So resultant vector of these two vectors, that is 3i plus 1j and B 1i plus 2j, is going to be 4i plus 3j. If someone asks, this is vector notation but we want in a layman's term, that is, what does it mean? It means, that is, the magnitude of this resultant vector is going to be, that is, we are interested in, that is, what is this? When we are interested in what is this, now let's for a timing forget what is this. It means we are interested in, number one, the magnitude of this vector, that is the length of this vector, and the second is we are interested in the angle of this vector. So we are using right now purely a layman's language, and we don't wish to use I and j terms. So for that, if you have to find this length, so this length in right angle triangle is going to be under root of this square plus this square. So magnitude of this r is going to be this square plus this square, that is 4 square plus 3 square. This is the magnitude. And what is the angle? That is tan theta in this right angle triangle is perpendicular or base. It is 3. It is 3 units only. Don't confuse with j. J only gives the direction, that is, it is this way. That's all. It will not be 3j by 4i. No, it is not. Vector division is not a valid operation in vector algebra. So this length is, it purely treated as a simple triangle only, right angle triangle. So this length is 3 units, this length is 4 units. So tan theta is equal to 3 by 4, or theta is equal to tan inverse 3 by 4. And if we are understanding vectors in the layman's language, it means this person, if he goes from here to here, that is the length of under root of 16 plus 9, that is under root 25, that is 5 meter. If person goes 5 meter, making an angle of theta is equal to tan inverse 3 by 4 with the positive x-axis in the anti-clockwise direction, he'll find himself exactly at the same spot if he had follows these two vectors. That is, first he had gone 3i plus 1j, and then he had gone 1i plus 2j. He would exactly find himself over here, provided he starts from here. So this is how we can add the vectors in terms of I, j and k. We could have also a term in k cap also, and then certainly we'll add k cap terms in k cap terms only. And if we have a vector like, let's say a vector is 2i plus 3j plus 5k cap, then its magnitude on the same lines, once again we can use the Pythagoras theorem only, and its magnitude will come out to be this square plus coefficient of this j, that is 3 square, plus coefficient of k cap square, that is 5 square. So this is going to be magnitude.